We're good to go.
Oh, I think he's good to go. Okay.
Yeah. And the mix on.
There you go.
Hello.
Yeah, go ahead.
No sound?
I guess. Go for it.
No sound. Can you hear me? Good morning. No mix.
We're good.
Hello.
You can hear us?
Hello, hello.
We don't hear ourselves, so oh, okay. Oh, I did?
Hello. Yeah.
Hello, hello, hello.
Hello, hello. Test 1, 2, 3. You hear us, Noel? She's pointing up, picking up the point. Okay. Can you guys hear us in the audience?
There we go. I'm starting to hear a little bit.
Loud and clear. Good.
Excellent. I think it's just you or both of us here. Can you hear me okay? Do you hear? Oh, okay.
Okay.
We can't hear ourselves at all, so that's great.
All right, folks, let's get this session underway. Thank you for being here. This session, we're going to talk a little bit about a project that me and Luis have been working on for a couple of years. It's a pleasure to be here. Thank you for being here. You can hear us? Yes.
Oh, there we go.
There we go.
Okay, thank you.
Perfect. So let's get this session on the way. Quick introduction. My name, Rutger Blom, working as a senior consultant in Sweden at Proact IT, helping customers implement, design, configure, run VMware solutions. Been doing that for a while. And with me today, I have...
My name's Chanu, VCDX NV. I've been working with VMware for a while and do a lot of architecture design and help customers with their deployments.
All right, so today we're talking about a project that we have been working on from years, like I mentioned before. Today is a bit of a special day. We're only at the third slide and we already have an announcement. So just some hours ago, about 6 hours ago, we released version 7 of our SDDC Lab project. So yeah, if you go to the GitHub page for the project, you'll end up on that version as the current default. So let's start by going over a little bit what is the project and what it does do for you and how is it used. It's basically a set of Ansible scripts that you use to automatically deploy nested VMware software-defined data center environments. And that's done in its core by using Ansible automation language. So we're using Ansible language to deploy these we call SDDC pods in your environment. So the way you use this is if you want to have a lab for learning stuff, or you want to do some testing or developing on your current VMware environment, but you don't want to do it in a real life environment, you can just go and deploy one of these software-defined network pods, software-defined data center pods, and get on the way. Another use case, of course, is if you want to do a proof of concept, do some testing, maybe figure out if a product is doing the right things for your organization.
Is the experience and overall results similar to like SDDC?
Yeah, good question. So the question was, is the experience the same as the holodeck project that's also out there? So it's a little bit different. I would say the focus for our project is not so much to deploy a VCF stack or to get that up and running. It's more about the product itself within the VCF stack. So we don't care about things like SDDC Manager. We just get you up and running with vSphere, NSX, and vSAN, etc.
And we also use release GA code. So that's one of the big, from using other options that are out there. When a new version of code comes out, you can go ahead and try a deployment to see if it's working, try upgrades, things like that. That was really the driver for a lot of the project.
Yeah, so some things we would like to point out with this project, how it is kind of unique. So we're using, like Luis mentioned already, let's hope this on the third bullet there, but we offer rapid and consistent deployment of SDDC environments, including vSphere, vSAN, NSX, Tanzu, and Area. Pods that are deployed can be connected to your current network, so you don't have to. You don't have to run them completely isolated. You can connect them over layer 3 to your current network environment, which means you can do either through static routing, some kind of dynamic routing, BGP, USPF. You can access your pod and the components. The third bullet point, like Luis mentioned, we're using only official installation media from Broadcom. So no special UVAs or any special things going on. You just download the installation media from the, well, it's not called the customer portal anymore, but from where you download your media, you put it in your library and the project can pick it up and make it work. Also, we really work hard on trying to implement an environment that is as much as like a real production environment as possible. So we use the good practices that are out there. So a lot of things that you find in VCF or in the VMware validated designs before, you'll find back in a pod as well. So we're not trying to take any shortcuts. We're just trying to set it up the way you would set it up in a production environment.
The other thing too I'll mention is that once it's deployed, everything is configured, including NSX. We've got the edges, we've got overlays. We're supporting V4, V6 on the overlays. BGP is all configured. Everything is configured, ready to go. So it's not just a deployment of the software. You really have a full-blown environment that you can start doing POC testing or whatever you like.
Exactly. So let's see, Luis, why don't you take us through the components of a SDDC Lab environment?
So with the SDDC Lab, first we have an Ansible controller. And by the way, the README on the GitHub site walks you through on how to set this all up. It's step by step by step. So if you don't know Ansible, it's okay. We give you all the commands, and we also have some other documentation for your first pod. So the first thing you'll do is you'll be setting up an Ansible controller. That's just a Linux box, and again, we give you all the commands to do that. And then after that, you will need a layer 3 switch in your environment. The idea is that the POC or the SDDC is separated from your environment. We don't want to leak any dynamic routes into your environment. At the border, everything should be statically routed so you have control of it. And that's all talked about too in the README. So then you'll have often your corporate DNS, because where we see this deployed is for a testing environment. So you'll want to be able to have corporate networking and then your SDDC environment to do all your testing. And we have our own DNS domain that we use for all of the resources that we spin up in the SDDC. We then have this router link, and the router link is just a segment that connects to the physical layer 3 switch. And in this is where we also deploy our DNS. Can you go ahead and, yeah. So we have a dedicated DNS for the lab environment. And so when things spin up, it'll register V4, V6, so A or quad A records, depending on if you have it enabled or not. We also have within our playbooks the ability to go ahead and deploy that DNS for you. So you can configure the config files, as we'll show you, and one of them could be deploying your DNS. So if you're not familiar with bind or anything, we handle the full deployment of that for you. We do support, because I mentioned V4, V6, OSPF v2 and v3 at the edge there to peer with your layer 3 router at the edge. We also do eBGP. So the way that we work is we have a pod sort of design. At the edge of our pod, we have what we call a pod router. And then below that pod router, we have all the components of a pod. Go ahead and, oh, there it goes. And so here's where we have our vCenter, our VRLI, we have our ESXi hosts. And by the way, when you configure the config file, you can indicate how many clusters you want, how many hosts in a cluster, the memory requirements, all of that is flexible within the config file that is used to deploy this. And so you can have multiple pods. So you see here 220, 230, 240. And so you can deploy up to 24 pods in a single lab sort of environment. Sorry? Oh. Yes.
Is this assuming multiple discrete hosts, or is it more it takes a got to be discrete hosts, or say a nested environment in your resources?
So the question is regarding the host for this, correct? So we can deploy in two different methods. If you have a single host, we can deploy this to a host. If you have a vCenter environment with some dedicated ESXi hosts, then you can also deploy to there. And there's some other benefits if you're using the vCenter over the single, but you can deploy this full environment that we're looking at here in a single host. That's what I do. He tests out the vCenter, I test out the single host to make sure that they're both functional.
Yeah. We have a slide. We have a slide on that later on as well about the
Yeah,
how you can.
we'll talk through all of that as well later.
Is my mic working? It seems to be not working. It is? Okay. So yeah, maybe I could just talk a little bit about what's in a pod. So what we deploy for you by default, if you do not change the configuration file, you'll get a pod router, essential to connect the pod to the outside world, and also to give a kind of peering point for the NSX installation in there. We have a vCenter server, obviously. We have a bunch of ESXi hosts that can be in one or more clusters. We configure vSAN storage for you. We have an NSX local manager, NSX edge nodes that are being peered to the pod router. And then we have area operations for logs, as it's called today. So that's what's being deployed by default. If you just take the config file, make a minimal amount of configuration changes, that's what you end up with in a pod. Additionally, you can enable things, and actually the first bullet there where we mentioned the DNS and NTP server is something we highly recommend. So this is a DNS server that's dedicated for all of your pods, not just one. It can be for all of the pods that you will deploy in the future as well. We fully configure an Ubuntu server with bind, with NTP, with all the zones, forward and reverse. And it's just, configured for auto-updating and stuff like that. It makes life much easier. If you do not deploy that DNS server, you are a little bit on your own. You need to make sure that your DNS server that you already have can do auto-updating and stuff like that. Advanced load balancer is in there, or you can enable it, fully configured and integrated with both vSphere and NSX. You can enable Tanzu Kubernetes grid servers on the cluster. You can also opt in for NSX Federation if you want to play around with that. That's also a multi-pod kind of solution we put in there, of course, because you'll need multiple pods to kind of simulate the multiple sites. A vCenter server can be configured in enhanced link mode to link the vCenters together, have a single pane of glass if you want. And then, of course, we support both IPv4, IPv6 for the NSX overlay segments that we're creating in each pod.
I just want to point one thing out is if you do want to go down the road of deploying dual stack on the overlays, make sure when you deploy the DNS server that you deploy it in v6 capable and ready and with a v6 address. Because once you deploy that, if it's only v4 and later on you want to do v6, you do end up having to deploy that. There's no harm in doing the dual stack from the beginning.
Okay, Luis.
So what we have here is the networking pieces for the pod. So every pod is assigned a number between 10 and 240 on a boundary of 10, and you'll see why as we get more into this. This is what the config file starts to look like at the very top, and here's how we define the pod number. As it gets deployed, everything is based off the pod number. So if you take a config file and you duplicate it multiple times, you change the pod number, everything, you'll now have different pods deploying, all different addresses, everything like that. So there's no overlapping from that perspective. So all the networking elements, as I mentioned, were driven by pod. The VLAN IDs are all driven by pod. Everything is really pod driven, including the overlay networking. That includes no duplicate, mentioned that. At the heart of the edge, we're using the VIOS software router. So at the very top, where the internal concept or the internal items touch the edge router segment, that's the VIOS router, and we do spin that up. We fully configure it and everything. The other thing too is the gateway interfaces within the pod itself are handled by the VIOS router. So we have, the reason why it's every 10 is we allocate 10 VLANs within a pod, and you'll see what those are used for in a moment. And here they are. And so if we have a pod number of 100, our VLAN IDs are going to be 100 through 109. So you have to take this into consideration because in your underlay that you're building this all off of, ideally you want to make sure to have from VLANs really 1 all the way to 249 fully available because you're going to be leveraging some of that potentially. So these are the various segments that we utilize for each pod. We start with a management. We do have vMotion and vSAN. We do separate out the vMotion just like you would in a production environment. We do also have IP storage, even though we don't really use it for anything. There is an option to leverage NFS. Also the NSX for overlay for Geneve traffic. Then we have service VMs. Even though we don't deploy any service VMs, if you wanted to try any service VMs, we have a segment for that for you. So you can try that out. The 2 edge uplinks for our NSX edges. So we do ECMP, just like you would do in a production environment. And then finally, we've got our RTEP for if you're planning on doing federation. Again, it'll fully configure all of that for you. And then finally, a VM network just to throw VMs on if you need to. So these are the 10 different, those were the 10 different VLANs that are part of a pod configuration. So regarding networking, this is one of the areas where we get most questions on. So we're gonna have a couple slides here talking through the networking to try to help explain it. You can deploy this in a single physical server, at which point everything's on that box. You don't need to worry about some of the layer 2 aspects of it. And you just have to configure an uplink to this SDDC Lab _VDS. And there's a network diagram that's coming up that I'll point this out a little bit further for you on to look more clear. Otherwise, if you have multiple servers, you can think of it as you'll have a single connection up to the layer 3 switch, and then you'll have a number of ports to a layer 2 switch. You can leverage a layer 3 switch as well. The diagram will make this make a little bit more sense. You actually can separate the two out or combine them into one switch if you have all the VLANs capable. Probably the network diagram does a better job of. So here's a diagram I put together. Here's our layer 3 switch. Here's our VIOS router. We have the uplink. This is you manually configure that. Here are the port groups that are automatically programmatically created for you by the SDDC Lab. So if it does not exist, it's your first time you're running it, it will spin up and create you all of the appropriate port groups that are needed for your pod. And so as you can see, 10 for each. These are not actually created, we just included them here so you can see how they're laid out. These are the interfaces. We talked earlier about the VIOS router provides the gateway for all of the internal networks. So that's what these are. These are the VLANs will terminate. So these are kind of SVIs within that networking bubble, which we call the pod. And then this gets you out to the real world outside. So that's how the networking functions. This right here is all layer 2. This piece here is layer 3 to get out. You can combine these two switches. There's no problem with that as long as you have the appropriate VLANs available on that layer 3 switch to leverage for the layer 2. And this is also in our README, so I know I'm kind of go through it quickly, but it is all there. Rutger, why don't you go ahead and talk through this?
So the project is kind of built on top of a couple of configuration files. These are the ones that you should kind of pay attention to. So we have a couple of files here. As you can see, we have a couple of example configuration files, I should say. And these files are basically a good starting point for you when you start to deploy your first SDDC Lab pod. Just copy those files to your own. Commands are down there. Just simple copy to your own files and start making modifications to those. So just a quick rundown of the files. We have a config YAML. We're going to look at it a little bit more in detail in the next slide, but it's kind of the blueprint of your pod to be deployed. It contains all the settings, all the products that you're going to deploy, which IP addresses, etc. So it really is the main dictionary, if you will, for your pod deployment. We have another file called licenses.yaml. In this file you will enter your license keys. So the license keys that you have from Broadcom, you'll enter there for every product. And what we'll do is when we deploy the pod, we'll automatically assign the licenses to the products. So once the pod is deployed, it's licensed and ready. The software YAML file contains a dictionary of all the different pieces of software that we can deploy. So think of vCenter, its different versions, all the way down from 6.7 up to 8.03. The same goes for ESXi, NSX, Advanced Load Balancer, etc. So it's basically a dictionary of what we support to be deployed in a SDDC Lab pod. The templates ones is a file that contains kind of paths to different template files that can be used for your deployment. You can make changes to it, but I do not recommend that you do that. At least not in the first time you deploy a pod.
You might want to talk through.
Yeah. So like I mentioned, when you clone the repository from GitHub, you'll end up with these sample files. just do a simple copy of those files, your own files. Just take away the sample in the file name, and you're good to go. You should, of course, then edit those files, but it's as simple as that. So the config YAML, like I said, it's a POTS blueprint. It has a lot of settings that you can modify, but only a few settings that you really have to pay attention to. So especially like we mentioned, if it's your first pod, don't get overwhelmed and scroll through the whole file. It's over 2,000 lines of YAML. Just stick to the most necessary points. Make sure it's compatible with your environment, and you should be good. So here's a screenshot of the most essential settings. We want to know things like what's the password to your physical ESXi host or your physical vCenter server. What's the IP address to your DNS server and NTP server? Things like what is the FQDN of your vCenter or host that we're going to deploy towards, the data center, the cluster, etc. So these are settings that you should be looking at. The rest basically is more or less good to go. I wouldn't bother about it.
There is one item I just want to point out. If at all possible, it'll make your life easier on your initial deployments. If you have this address space available, the 10203, please use that. There's a lot driven by it. You can definitely change it and it will flow throughout, but it makes it easier for troubleshooting because every time you look at some documentation or examples, it'll always be on the 10203, so you're not having to think through that.
So let's have a quick look at a pre-recorded demo. So this is the config.yaml. As you see, it's a huge file. Just pointing out the essential settings. Most of them are under an item called common. This is where you would enter your password, for example, for your ESXi host or the vCenter server, DNS and NTP server. There are all things in there as well. Next is the target config. That's the target where we are going to deploy your pod onto. So obviously you want to make this decision if you're going to deploy to a host or a vCenter. And once you decide that, you need to, of course, update your FQDN for the correct vCenter. The data center, your cluster, your data store, etc.
So you're defining your environment here. Like the question was a vCenter or host. You just specify at the top there was an option for vCenter or host, and then it uses the appropriate section to deploy the entire lab.
So one thing to point out as well is how do you connect your pod to the outside world? Well, you can do it in a couple of ways. You define that under the nested router setting called protocol. So you can either say, I want to connect it through static routes, USPF, BGP, or both. So it's up to you. There's a lot of flexibility in there.
So here's an example of the software.yaml file. We have all the, I know it's a little small, but we have all the different software versions like vCenter and then the version numbers, and then below it are information about that piece of software, including the file name and a path to the directory where the software library is held. So when a new version comes out, you download it, you can add it to the software library, and then at that point it's available for you to use in the lab. And so this right here is the software YAML that's defining all of the different artifacts for the software components, and this is what the /software library or directory structure looks like. It's laid out, we have the products, the different versions, and below it we have the code, the actual OVAs or whatnot that is used. And this is leveraged by the product or by the SDDC Lab. When you go deploy it, it verifies that the software is here, and now it knows where to go get it, and that's the OVA that it then uses to do the deployments. So this right here is regarding the config file. So when you create the config file in the YAML, you then, when you're done with your configuration, you have to do there's a process for creating what we call a static pod config. And this is to optimize the deployment. So what you do is you change into the directory where your YAML file is, where your configuration is. And then we have this Ansible playbook called create pod config. Again, I know it's a little small there. On number 2 there, and it actually prompts you, where is the file located and what is the file that you want to prepare? Well, it's the one that we're showing up here. So it will then, you enter that in, and it will start processing that file and create a static version of that file in YAML. Then it even tells you a little bit about where it's generating it to, the source and the destination. The other thing we do is with the actual config file, once it goes through the create pod config, is it actually includes the versions of each of the different products that are in that are part of the lab that's going to be deployed. So you can have multiple config files that are generated on all the same day with all the different types of versions of different products, and they're all there for you to choose. And when you look at the directory listing, it's really easy to see which one is which, and you can just deploy that particular YAML file. It also has a date that the pod creation took place at the very beginning of the file, so that if you have a whole bunch of different dates, they all sort together. It makes it easy to manage your config library. At the very end, after the pod config is finished, which only takes a few minutes, at that point, we actually give you the full command that you would run. So you can copy paste this entire line, go back to the command line, paste, hit enter, and the pod starts to deploy.
Yeah. Talking about the pod launching the pod deployment. So is that command is being in the output of the pod configuration Ansible playbook. So once you deploy. Once you run this command, and if you look at it, we use the static config file as the input on the deploy YAML playbook. So it will take all of your parameters and use it to set up the pod the way you have configured your settings. Just a quick screen what it looks like. So we have the command up there, and you just launch the pod, and we start doing things like, and that's pretty good to mention as well, we do a verification of all your settings just to make sure that you have the ISO files in place, you have the right prerequisites in place to actually successfully deploy a pod. So it would be a bit boring to, after 1 hour, get a message that your pod failed to deploy, just because you missed to download the right UVA file. So just, nothing special here, just running through the different tasks. We don't have to look at it entirely, be short on time as well. Eventually, you'll hopefully end up with this type of report where the tasks are done, and we have a successful deployment. This is on my a little bit older home lab hardware, so it took a little bit more than an hour, to be honest, but you should be able to get it done around an hour. Yeah, short on time. So just some last slides, if that's okay. Once we have the pod in place, just showing you the vCenter interface. We have, in this case, a default deployment consisting of a compute cluster with some ESXi hosts, running the latest version in this case. We have an edge cluster dedicated for running the edge nodes for NSX, running there as well. And this is, of course, configured with the vSAN storage. Each cluster has its own storage, and besides that, we have the pod networking port groups, including the NSX segments that we are setting up for you. Do you want to take us through the NSX slide?
Yeah, so this is essentially what the final deployment looks like. We have our edge networks going out to the physical world. We have our tier 0, tier 1s, and in our configuration, we have a few overlay segments that get created.
Yeah, so also provided is a documentation. When you deploy a pod, the first thing that's created is a pod documentation file. It's an HTML file containing all the information around your pod with links, so you can share it with your colleagues or bookmark it or whatever, just for you to easily access all the components. Yeah.
Okay, we got it.
Yeah.
So
no time for questions, but we will be around here.
Yeah.
You can ask us anytime. Thank you very much for your time.
Much.